Yeah, hello. We're here once again. Today, we're going to talk about relays. Um, Relay, and we're going to talk about its use, how to use them, and how to wire them up. So let's go to the table and see how we can do that. Let's understand some of the diagrams we have. We have different types of relays: 4 pin, 5 pin, 7 pins. But let's concentrate on a 4 pin relay. So we can say, just do some diagram and say, this is a kind of relay. We have a prone here. There's one there. There's another here. And then there's another that way. This is a 4 prone relay and it has numbers. This particular one has number 30. And this one has 86. This one 85. And then this one 87. Okay, that's what we have on the prawns. So we're going to show this one practically for you to understand. But what this means is that the 30 will have to take in power that we use to power your device, and this power have to come through 87 to power your device. 85 and 86 can be interchanged. One has to come from a power source positive, and this one has to come from a power source negative to energize the relay to be able to have connect this prone 30 to 87, make contact with these two so you can power your device. So basically that is the drawing to illustrate a relay. And let's push this side. This is what we have as a relay. I don't know if you can see. Okay, so that is, we have a pin 30 here. You can see pin 30 down here, and then we have 87, and we have 86 on the left and 85 on the right. So 85 and 86 are just prawns that will need negative and positive to energize the whole relay. And then you connect your power source through 30, which will then come out from 87 to power your device. So it's as simple as that. The numbers are just indicators. So don't let these numbers confuse you. They are just indicators to identify the prawns. So let's move on and see how many, the type of um, relays we have. Okay, this one is a 24 volts 40 amp relay. So please take note of the ratings. We have a four pin relay. This one is a 5 pin relay, but basically they all do the same thing. And we have another relay here. You can see this one has three here, three there, and then a big one in the middle there. And they all do the same thing, but just slightly different. It has a diagram by the side. So if you are good in reading diagrams, that is pretty good for you. We also have this one, which already have wires connected to it already. And if you don't like this one, you can just make your own. Or assuming we don't have this one connected to it, you have to create your own prawns wires to this and make the connection. But this one comes with it. Okay. Now that we have our cables already made, this one is inline fuse. So my cable has been fused. Forget about this place, it's just a joint. This is an inline fuse where you have to fuse this particular cable. And we're going to use pin 30. So I don't know if you can see here. So pin 30 here. So this, sorry, let's use pin 85. So 85 is there. And then we have to connect this one to 85. And then connect the negative lead to 86. To 86. And that goes to 86. So we have 85, 86 connected, and these two powers are going to energize the there's a coil in there, electromagnetic coil. So when it gets power from the battery, it energizes and made contact. So we cannot get power through this pole and this pole. So these two will have to power the relay to energize and make contact with these two poles. So let's see if our relay is really working. Let's test it and see. So I have a battery here. I take the two ends, sorry, okay, I take the two positive and negative end and then try to see if I can energize the relay, and it should have a click sound. You should make a click sound. Okay, so here you can see that. Okay, I don't know if you can see my, yeah, that's my battery. So just negative and positive, and we are getting a click from this relay. So this one will energize the relay for it to have a contact. We are left with pin 30 and pin 80. That's 87, pin 87 and pin 30. So our lead goes to pin 30, and this particular one is the one that is going or bringing in power from the battery. So the 30 takes power from the battery, and this power is the one that will have to go through this prong to this prong to be able to power a device that you wanted to power. So we're going to connect our device to 87. That's what we're going to do. But unfortunately, I don't have anything like a light to show, but I'll use a small fan to connect that and see how it works. So let's connect the other prong. Our device is here. We have a small fan to power, and as usual, we take our power source from the battery or wherever, and then the power source will have to go into pin 30. This is prong 30, and that power 30 will go through pin 87 and will have to come out through 87 to the device we want to power, the positive lead of the device we want to power. So it goes into the positive side, and then we tie it to our device that we need to power, but then we have to tape it just to be on the safer side. So that is done. Okay, so from pin 30 power to 30, it goes through 87 to our device, and now the device negative lead will have to be grounded. So I have grounded the positive wire from the device here, and that goes to my power. If it's in a car, you say you can just tap it to the body, the chassis of the car. We call it ground, but in this case, let's call it negative. So the negative device goes to the negative of your battery. The positive will have to come to the relay switch, and then it goes through the relay switch into your device. Now we need to energize the switch itself, which is the relay, and therefore we take pin 85, power into pin 85. So I take the power source, and it goes through a switch. The power source comes through a switch and then comes out from the switch, and then I fuse it back into the relay. That is the positive line, and then the negative comes from the other end into our negative post, or we can say our ground. So that is the connection. I hope you can see clear. Now that we have switched it, all we need to do is to turn our switch on to see if this fan will turn on. Yeah, it's working. Off. So as you can see, on, off, on, off. So just a quick recap. This is our device we want to power. The device might be a very heavy duty device that probably draws a lot of current, and that is the main reason why we have to use um, this particular relay switch. It draws a lot of power, currents, and therefore you can not just use heavy cables all the way from your switch, a switch like this, to your device. You can't do that. It is too heavy. Might be too long away from your power source. Therefore, you only have to introduce a switch, and this switch that energizes these two 85, 86 cable can be very tiny as anything. It can be as tiny as anything, and it can be as long as a distance as any distance you want to think of. So you don't necessarily have to be near the device to turn it on. The device can be connected through um, a relay switch, and the relay switch will have to probably energize itself and give a contact to the device to come on. But the switch, to make it possible, can be far away from the device, and that is the essence of a relay, so that it can easily carry a higher amperage to your device, because devices such as fans, heaters, and so forth can draw a lot of current. And if you don't use a heavy gauge, if you don't use a heavy wire gauge to connect to that, the device might generate heat, and that will cause problems for you. But as long as it is closer to the device, and you can use just that short distance higher gauge, that could save you a cost. And then you can use the tiny gauge a distance away from your device, and you can power it. So as you can see, I just use a common normal switch to turn it on.